Okay, Algebra 2 skills number 31, square root graphs. We're going to look first at what a graph is. A lot of people don't realize what a graph actually is. It's simply a picture of all solutions. Okay, solutions being ordered pairs that make an equation true, or values of x that make an equation true. So that's what a graph is in math. So this is the parent function, which is the simplest function for the square root family. Y equals the square root of x. There's no numbers in here. There's no minuses, anything like that. It's just simply y equals the square root of x. And you can see several points here from Desmos that were highlighted. The square root of 0 is 0. Okay, that's why 0, 0 is on there. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3, and so forth. And you might imagine here that as you continue, the gap between the x value and the y value is going to continue to widen, because the square root of 16 would be 4, the square root of 25 would be 5, and so forth on down the line. That's causing this graph to kind of flatten out. So this is the typical shape of a square root that we need to get used to. Now, domain and range is also a concept that's used in algebra with graphs. And the square root graph is probably the best one to illustrate domain and range. Domain, from a graphical standpoint, are all x values covered by a graph. And you can think of it as leftmost to rightmost. So what are all the x values that you possibly see for a graph, and you have to consider if the graph were to continue forever. The range would be all y values covered by a graph. And since the y-axis is vertical, you can think of that as lowest to highest. Okay, so we're going to show you two different ways to show the domain and range. So look at a couple examples. So here at example 1, you're to graph, tell the transformation or transformations from the parent, which we've already pictured, and provide the domain and range. Okay, so this is the first example. If you've seen the previous video, or if you're familiar with graph transformations, you know that if you add on the outside, you go up. Okay, so here's the parent in blue. It's dashed. The red graph is the one shown here, and it's the exact same shape. It just went up 3, because that's what happens when you add on the outside. So we've graphed it. The transformation, you can say, is a vertical shift up 3, and sometimes people just say shift up 3, or just simply up 3, which you can easily see in the picture. Now the domain, let's go and get into, or first before that, starting point is 0, 3. And again, if you've seen the previous video or the graph transformations video, this 0 comes from what you adding on the inside, and this 3, and you change the sign, but here it's 0 anyway. And 3 is what you add on the outside. So that's where 0, 3 came from. And I color code that because the domain uses that first number. Okay, and this may be confusing if you've never seen this, but these are two different ways you could write this. Okay, one way would be x greater than or equal to 0. That's leftmost to rightmost. So if you look at the red graph, you're only looking at these coordinates right here. Okay, you're not paying any attention to these coordinates, only the x's. And the leftmost, if you're using, see my arrow here going back and forth, the leftmost point would be 0, and the rightmost point would go on forever as we assume this graph just continues in like fashion. So we can say in what we call inequality notation, x is greater than or equal to 0, because you're there at 0. Again, we're looking only at the x coordinates, and you continue forever to the right. But there's also something called interval notation, which tends to be introduced in Algebra 2. Interval notation literally writes down the leftmost and the rightmost. And sometimes you don't have a number, you actually have the concept of going on forever. So this is the concept of infinity, which is not a true number. It's just the concept or idea that you will continue forever to the right, that you'll never stop going in that direction. Now the bracket and parenthesis, you'll get used to it as you do more examples, but the bracket means you can be equal to this endpoint, so you can be equal to 0. It actually touches 0 here. And the parenthesis means you cannot be equal to the endpoint. Remember, infinity is not a number. Therefore, infinities always get parentheses. Okay, so these are saying the same thing. It just depends on which way you're to write it. So for range, it's going to use only these coordinates, only the up and down. Okay, it's lowest to highest. The range, so you see it uses a y instead of an x, and it uses this blue number from the starting point. So y is greater than or equal to 3 because, looking at these coordinates, it starts at 3 and it goes upward forever. And the same concept that we discussed just a moment ago, the bracket here means it can equal 3, and the parenthesis means it cannot equal infinity. So range literally is lowest to highest. So in this case, 3 to infinity. A second example. Again, same instructions. Now here we've got more going on, so it's a good way to review your graph transformations. There's quite a few of them here. First is graph it. So notice that the graph is down here and it looks a little different. So let's talk about the transformations. It's got a vertical stretch by a factor of 2, okay, which means, if you remember again from the graph transformations video, or if you're familiar, a stretch is when you multiply by a number larger than 1 or less than -1. It makes the graph either more narrow or steeper depending on the shape. So here it's clearly steeper. Horizontal shift right 1, that comes from this one where you change the sign on the inside. So you can see if the blue is the parent, then the red graph is 1 to the right. And then down 5. You don't change the sign on the outside. Okay, so it's clearly 5 below. So the starting point here is 1, -5. Again, looking at these numbers, changing the sign on the inside and not on the outside. Notice also that the 2 in front is not relevant with a starting point, and it won't be relevant for neither our domain nor our range. Our domain, which is the exact same concept as example 1, all values, again looking at the red graph, from 1 to infinity. Okay, we don't care that it's down 5, we only care that it's 1 is the leftmost and infinity is the rightmost. In our range, -5 to infinity, or y greater than or equal to -5, again reading only these numbers, and it starts at -5 and it goes up forever from there. So again, looking only at these numbers. The brackets again mean you can be equal to 1 and -5, but you can't be equal to infinity. Now you may notice that this seems like a simple pattern based right out of the starting point, and for many examples it is, but yeah, there can be some curveballs. Let's look at one more example. So here, again, looking at their transformations, notice that it's the same basic shape, but there's clearly some things that happen. It's upside down, or in this case, it's a reflection in X. Of course, it got shifted as well, but it is reflected right over the X-axis. There's a vertical shrink, which you remember that's multiplying by a number between -1 and 1, which makes it flatter or wider, in this case flatter. And it's left 1 because of the 1 on the inside. Okay, so domain starting point is still -1, 0. You change the sign on the inside. There's nothing outside. And by outside, we mean what we add to the outside. We're not talking about -1/4, which again is irrelevant to domain and range here. And you can see -1, 0 is the starting point there. The domain is just as before. Even though it's upside down, domain doesn't care. Right? It goes left -1, it goes right forever. But here's your curveball. Range, notice it's backwards. It's less than or equal to 0. We only care about these numbers. And when we look at our interval notation, this is a little weird compared to the others. It's lowest to highest. You can't ever do highest to lowest. It's always lowest to highest, just like it's always leftmost to rightmost. So you go down forever. You must report the smaller number first, and it goes up to 0. Again, we only care about these numbers. Only care about the y's. We don't care that there's a -1 here, and it goes down forever and up to 0. The bracket again means you can be equal to the 0, it stops there, but you cannot be equal to negative infinity. Negative infinity is the idea of going in a negative direction forever.